Welcome to today's lesson for chapter 2.1, looking at transformations of radical functions. Very short video today. It relies a lot on what we know about inverses and about transformations. So we'll start by trying to look at graphing the equation y equals the square root of x. Now, we know what this kind of looks like already from our work with inverses, but if I wanted to make a nice data table for my x's and y's here, I want to think a little bit about the values that I'm going to use. Since I'm taking the square root of x, I want x to be perfect square values. So I'm going to start with 0 and 1, and then I'm going to have 4, 9, and 16. I'm not going to get 16 on my graph here in a second, but I'll get those points in. So square root of 0 is 0, square root of 1 is 1, square root of 4, I get 2, 3, and then 4. And if I look at the graph that I have over here, we see what we've already seen. We have half of a parabola on its side. But in terms of thinking maybe about mapping rules as we go to start doing transformations on it, being able to think about what the nice data table would look like, so I'd be able to have points that I'd be able to easily graph, is a really good thing for us to do. So the next thing that we're going to do we got to do domain and range first. So if I look at it for both domain and range, I see that for the domain, x has to be equal to 0 or greater than 0. We're going to use proper notation, or sort of full domain range notation here. So that first little bit, the x and then the vertical line, just tells me that the variable I'm talking about is x. X has to be greater or equal to 0. And then x is contained in the reals. And then I'll do my range. And when I look at my range, y starts at 0 and is greater or equal to 0. Now, it grows a lot slower in y than it does in x, but there is still no bound on the y values. It's going to go all the way to infinity. All right, so now that we have a function graphed and we've taken a look at the domain and range, we want to look at this transformed function, and we want to run through and see what's going to happen with all these transformations. So what I'm going to do is we're going to sketch out just that first graph that we looked at. And then we'll just identify our transformation. So when it says, can you write this function in terms of its transformations, I'm really just asking you to describe them. I'm going to identify all the transformations, and we're going to graph them. So the first thing we see is a reflection in the x. So that's going to give me a graph that looks like that. The next thing we see is a vertical stretch of 2. So I'm going to get a graph that's not to scale, but gives us an idea. The half, I'm going to write out my b value first. So my b value is a half, which means I have a horizontal stretch of 2. So that function sort of lies in between those two as we start to stretch it out. Again, these aren't to scale. I'm just getting basic ideas of what these transformations are going to look like. And then I have a vertical translation of 3. And so I'm just going to move that up, and it's going to look something like that. I know the y-intercept of that function because under all the reflections and the stretches, the origin point isn't going to move. It's going to be invariant under those specific transformations. And then I'm going to slide everything up 3. We need to do domain and range. So I can see with the domain, nothing's changed, right? I still have, so we're talking about x is greater or equal to 0, and then x is contained in the reals. For my range, what's changed now? Well, there's 2 things that have changed. I flipped it upside down, so I'm going down to negative infinity, and I've also slid it up by 3. So now y is less than or equal to 3, and y is contained in the reals. And that's all there is for our lesson today. Short and sweet. We're just really applying things that we know from all of Chapter 1 together to look at the inverse of a parabola or inverse of quadratic functions. Make sure you have any questions that you may need answered ready for class on our next day.